So this is the QMX. Let's open the box. It's from QRP Labs and I've been waiting quite a while to start building this. Very tightly packaged, as you can see. So what have we got? Nice little case. It's actually smaller than I expected it to be from the videos I've seen. Very neat. This is the main board. The surface mount components there. I'm going to look closely at that under the magnifier and make sure there are no problems. I noticed the foam wrapping over these inductors. One of the things in the educational video was about how they had early problems with these being broken in postage, but they look good. So yes, we have to disconnect these board pieces. There's a central one, little board here, and then the main one. And I think this is an extra connector. We'll figure that out. I have to start looking at the instructions. I have briefly read them through, but it's been a while. Some cables. Ferrites in there. Power cable. Oh, this is an extra that I ordered. I ordered the dummy load. I saw someone from QRP Labs making a dummy load and then using it as a way to measure the power output, because he had it in a tin and he had an extra external connector, and I thought that was a really good idea. I've actually got my own 5-watt dummy load here, but I think this one might be more than 5 watts, I can't remember. That's another little project. Looks like mechanical components in this bag. Let's see what's in here. Ah yes, the display. As you can see, I'm earthed to this table. I'm keeping everything nice and safe. Ah yes, and some more of the case here, case components with machine screws from the look of it. Put this here so you can see it in the frame. Right, I think at this point I need to go find my iPad and bring up the extensive instructions and see how to put this thing together. And just to give you a closer look at the board, let me put my wrist strap back on here because I am a little paranoid. Hopefully you can see that. So the first part of this journey is to remove the pieces of the board. So let's get on with that. Put a little bit more light on the situation here. There we go. So this is the output transformer for the QMX. In the instructions it's called the really weird twisted sisters transformer. Apologies if you can hear my 3D printer in the background, it's quite busy today. So yeah, this is a slightly different design I think to the one they had originally to help it improve on the lower bands. It's not too difficult to wind. You make a twist of one piece and then you bend it out at the top here, then you add another piece and then twist, and then these pieces are fed back through in some way. So I'm just working on that for now. This is the like I say, the output transformer of the radio. Now I've pulled the twisted sections back through the ferrite. Here we are with an extra loop, so had I realised that I had to pass this through the holes again, I might have even twisted these even tighter just to make room, because it's quite narrow down there to get 2 turns through each side. But there we go, that's the winding done. Okay, so here I have cut the hairpin and untangled the wires, bared some enamel, and I'm going to put it on the meter now and make sure that I've got the connections correct without any shorts. And then I have to identify which pair of these I need to twist together. As you can see, I had to try hard there, but yeah, indeed these 2 outer wires have conductivity between them. Probably didn't scrape enough enamel off to get a good contact. It's good that the others don't have continuity, because that means I got it right. Again, I'm having trouble making a connection. There we go. Yeah. So now I've twisted together the pair that don't conduct, these 2 with a connecting pair. Let's see what's next. So I got a bit nervous because I had problems with this side not being conductive with this side until I realised that depended on this twist up here, and they weren't necessarily in contact, these both sides. And when I adjusted this pin here, I could get a connection to here. So this is correct. These 2 pins here are conductive with this one, and these 2 are conductive with each other, and none of the P's or S's, as you can see in the diagram here, interconnect. I'll just use these clippers to get me a better contact. I'll probably need to get some kind of clipper ends for my DVM, but that's a job for another day. There we go, it's soldered on. I've done the continuity tests as suggested in the document. Everything seems fine. It did take quite a bit of effort to scrape these terminals and get the solder in there, but looks like we're good to go with that part. It took a lot longer than I expected it to. There we go, there's the output transformer soldered into place. I've done all the testing, all the tested points, and it seems to be fine. So now I've moved on to winding this coil here, which, if I consult the instructions here, this is L401. It's got a tap at 15 turns and a 23 turn winding. So I'm just going to solder that onto the board. Well, I appear to have found a beer, so it's probably time to call it a day there. I've fitted this toroid here, and I've begun to fit the low pass filter toroids. There are actually 6 of these, and they all have different windings. So that's going to take me a little time to do tomorrow, but yeah, progress has been made. These toroids are a little fiddly to wind, and then it's quite hard to get the enamel off them so they're soldered properly, and they're very tight fit. This thing just slotted right into place with no room for error. So yeah, progress has been made. All for today. Okay, so as you can see, I made a bit more progress this morning. I've just finished fitting the connectors. There's a B and C, push to torque, the power connector there, the other two 3.5mm jacks. And I finished the coils this morning. There was a lot of problems winding these. The winding wasn't so bad, but scraping off the enamel I found quite difficult. I don't know if my soldering iron isn't just hot enough, but I found it quite difficult to make a good connection with these. So I spent quite a lot of time. But as you can see, the windings on these are different depending on the band. I'm not sure if I just showed this transformer. This interestingly wired output transformer was tricky. This one had a trifilar winding, three cables together, all twisted. And that was okay. This one was tricky to fit. It's 10 turns on each side, and then there is another thicker enamel wire goes through the center of each hole in this binocular ferrite. So yeah, that was a bit more tricky to do. Just getting it to go inside in the correct holes. But I've probed everything out with a meter. It all looks clean so far. There was an extra little deliberate short there that you had to make. Yeah, so that's where I'm at. I'm getting close to finishing the main board now. Okay, so I finished the main board. Finished putting all the connectors on. Definitely one of the harder parts was fitting these little power supply buck converter boards. You see there's a right angle connector here. You had to kind of place them and then put the connectors on, then solder the tops, then take everything off and solder the bottoms. And there's quite a lot of narrow precision stuff here that you have to be really careful with, not to knock off this little diode while screwing in the screws, and careful of these inductors. So yeah, a little tricky getting that all together. I made a mistake as well. I misread the instructions, and instead of putting this 2x5 connector on, I put on the male connector instead. Thankfully, not so long ago, I bought this amazing solder sucker from Amazon, which does make the job of correcting those mistakes so much easier. It reminds me of the solder suckers I used to use when I was first employed as a kid in a production facility, and we had amazing tools like this that worked really well. So I'm really pleased I bought that, because it saved my bacon, and I think I managed to cleanly get the connector off without doing any damage. And then I applied some flux and used some desoldering blade to clean it all up, and then I soldered on the new connector. So hopefully I haven't done any damage there. We'll see. I mean, my odds of this thing working go down the longer I work on it. It's so complex. All the windings were difficult, getting all the enamel scraped off so you got good connections for all of these coils. I'm kind of a thorough builder, but this has certainly challenged me. I've struggled a bit, and it's been a lot of hours that I've put into it, so it'll be a shame if when I plug it all in it doesn't actually work. But let's stay optimistic and say that it's gonna, and we'll see. So the next part of the process is to build up the display board. There are some pieces here that it fastens into and then it connects over the top somehow, so I'm just going to take another look at the instructions and see how that goes. Okay, on the home straight now. This is the display board, which just consisted of soldering this board onto this second piece here and bolting them, two of them together. Actually, I think I've missed a couple of bolts off, but I've got to put a couple of spacers on here. This one attaches onto the main board eventually. I managed to skew the little potentiometer a little bit. Hopefully it doesn't matter, I can always adjust it if it's not going to fit. These were difficult to solder. I don't know why. I think this... Okay, after a long day, well, a long afternoon, I finally have the three pieces. We've got the main board here, the control board. I wasn't very happy with this. The rotary encoders, you're supposed to bend over these K connectors and feed them through to the other side, but the connectors were so short I had to add extra leads and faff on a bit to try and make these connections, so they're not as tidy as I would like. I think perhaps the rotary encoders that were used by the by whoever designed this had longer legs, but the ones supplied with the kit are certainly too short. They don't really go into the holes. The other thing about this board is it flexes a little bit, and once it's in its connector on the main board here, I'm a bit worried that over time these rotary encoders are going to cause connection problems, but we'll see. In the instructions it also recommends putting a piece of tape here, because when this board is on here it butts really tightly against the power connector, which would be a bad thing to short the two together. So yeah, let me put these three things together. Maybe I can do it on camera. We'll see. So you can see that one. This is the control board. Sits on there like that. This is the display board. I've still got the protective shield on here. And this slots over the top here and connects into these connectors. Now, I've done this once before. It is quite tricky. Hence, I was a little bit worried about doing it on camera, but there we go. We're in. Yeah, so there's the final. You can see what I mean about this. Actually, once I've screwed this down, let's screw these in. I like these nylon spacers and washers, very nice for electronics, obviously because they don't conduct. The only problem with these is they don't really seem to fasten terribly tightly. There is a certain amount of give in these, in the plastic, I think. But let's just fasten this together. The next step obviously is for me to start trying to bring this up, do some final checks. There we go. So as I said, there is a little bit of flex here. It's not too bad. Yeah, but a neat little unit. If I had a criticism, I would say, does it need to be this small? I mean, it's a tiny, tiny unit. I can't remember where I've put the box now, but the case is the same size. And it's hugely compact, right? It's got these buck converter power boards stacked. Very minute components. I get that it's a QRP device that needs to be out in the field, but I think that this design could have benefited from just being a little bigger and making some of the construction a little bit simpler. This is certainly a really advanced build. Anyway, we'll see if it works. As you can see, rather astonishingly, things just worked. I installed the firmware, plugged in my end-fed half-wave, which is a 40 meter version, and there it is decoding the moles. No one as surprised as me that it actually worked first time.